Turbopumps are essentially the heart of the engine. So if you think about the body, right, the heart pumps the blood everywhere that it needs to go. If you look at the fuel in the locks, that's what it's doing. That's what both of our pumps are doing. They're taking that working fluid and sending it everywhere that it needs to go throughout the engine. We run a dual shaft system, one pump specifically for locks, another pump for specifically the liquid natural gas. The first part that the fluid is going to hit is going to be the inducer. The inducer pulls the flow axially, and then it goes into things called external guide vanes. That will stabilize the flow, and then it goes into, at least on the fuel pump, it will go into our first stage impeller. After that, the impellers throw the flow radially into a crossover. Then it hits our second stage impeller. Between those two impellers is really where we get the pressure rise that we're looking for. Fuel pump full power is about 24,000 RPM, and the LOX pump is about 17,000 RPM. What makes our turbopump unique is we've really tried to leverage the PBF team and the printing side to reduce part count, optimize some of the flow paths, and really try to get the best out of it and make it as compact as possible.
The component test area here at our Long Beach facility consists of basically 5 test cells, which are used for testing various components that we design and build here at the factory, primarily used for valve testing as well as the turbopump testing.
This is our component test area. We take liquid nitrogen from our gas farm over there, and we can go ahead and put it into this run tank here, and we can pressurize this to a couple hundred PSI to give us a constant flow in order for us to be able to test our turbo here.
The testing we do here at Long Beach includes mostly component level testing, and once we're done with that, the components go back into the factory where they're assembled onto an engine and then go out to Stennis for the engine hot fire testing. Typical day during turbopump testing basically consisted of getting together with the test engineers and responsible engineers at the beginning of the day to talk through the day's plan before running the couple of tests that we were going to run that day. We run a variety of tests on the turbopump, starting with chill-in testing, where we monitor the turbopump condition as it comes down to propellant temperatures. The thing that sets the component test area here at Long Beach apart from some of our other test facilities is its proximity to the factory and where things are built. So we can go pretty quickly from assembling a component in the factory out to the test yard to get data and get that data back to the design engineers. Shortening that feedback loop really helps us iterate quickly and improve our designs.
And really after that, it's a process of design, test, iterate, more or less figure out how the hell to make it better. My favorite part of working on the turbo pumps is just the complexity of the assembly. It's fun to figure out the puzzle and work with the REs going back and forth as to what's actually going on inside these pumps.
One of the things I really enjoy about the test environment is being able to work with a cross-disciplinary team to tackle these complex projects.
What I'm most looking forward to on Aeon R, or Aeon R in general, is watching this thing fly. I love getting my hands dirty and being in there with the whole squad. That's what I'm really looking forward to.